Application of the ideal gas law. You can use the ideal gas law in combination with density and molar mass to relate density and molar mass to volume, pressure, and temperature. So if this is our ideal gas law, PV equals nRT, or PIV NERT, molar mass is grams, or mass, divided by moles. So what these two formulas have in common then is your number of moles. So if I take my molar mass and I solve for moles, I would have moles equals mass divided by molar mass. And then I can substitute it in to my ideal gas law. PV equals mass divided by molar mass, RT. So we can take our ideal gas law and our molar mass and do a substitution so that we can then directly relate molar mass to volume, pressure, and temperature. Density has the mass and volume. So if I take this equation and I rearrange it so that I have mass over volume, I would have pressure times molar mass equals mass over volume times RT. And then I can make my substitution for density. So PM equals DRT. So now I have two applications of my ideal gas law. I've related the ideal gas law to molar mass, and I've related the ideal gas law to density. One way of remembering the application with density is by remembering in the PM you are DRT. So PM equals DRT. PM equals DRT. So if we look at two examples using those concepts, in our first example here, we're given 1.4 grams per liter. Well, grams per liter is a unit for density. I'm also told at standard temperature and standard pressure. So I know my temperature is 0 degrees Celsius, which is 273 Kelvin, and my pressure is 1 atm. Alright, and so we're also looking for molar mass, and the symbol for molar mass is that capital M. So because I'm given these symbols, I know I'm going to use the application of the ideal gas law. PM equals DRT. And then I can just make my substitutions. So the pressure is 1 atm. I'm solving for molar mass. That's equal to the density times the gas law constant, 1, times my temperature. So to find the molar mass, I'm just going to simply divide by my pressure. So the molar mass would have to be 31.4, and then if we look at our units, atm cancels, liters cancel, Kelvin cancels, so we're left with gram over mole. Looking at another problem, we're given density again, we're given pressure, we're given temperature, and we're solving for molar mass. So anytime you have density and you're looking for molar mass at a certain pressure and temperature, then you know it's the ideal gas law application. So temperature is equal to 273 plus 25 degrees Celsius. So my temperature is going to be 298 Kelvin. Plug in my numbers, pressure times my molar mass, what I'm looking for, equals the density times the gas law constant, 0.821 liter atm over mole Kelvin, times the temperature, 298. So to get my molar mass, we divide by the pressure. we have a molar mass of 26.1. And then again, our units, liters cancel, ATM cancels, Kelvin cancels, and we're left with grams over moles.